Hello students. So I am here to represent one more video in our series of the polarization. If you guys have seen the last video, in the last video I told you that how basically we can say that how many types of polarization are there. What is a basically plane polarized light, what is circularly polarized light, what is unpolarized light, what is elliptically polarized light, we have basically discussed in the last video. In this video, I am going to tell you that mathematically how can you recognize if your electric field equation is given to you, how can you basically say, okay, just by looking at this, yes, this is the plane polarized light, or this is a circularly polarized light, or elliptically polarized light. So in this lead, I'm going to tell you a mathematical expression. I'll not derive here because it's quite lengthy. So let's suppose I have written here electric field equation, and it is given as, let's suppose, A cos kz minus omega t I cap plus B cos kz minus omega t plus phi j cap. This is a random electric field equation. Okay, this is a x component of the electric field, that is A cos kz minus omega t I cap, and the Ey is nothing but B cos kz minus omega t plus phi j cap. A and B are nothing but the amplitude. A is amplitude in the x component of the electric field, and B is the amplitude of the y component of the electric field. Okay, and phi is the phase difference between the two components. So what we have to do, first of all, we have to eliminate the time factor over here. Okay, how can you basically one of our main aim is to find out the equation of the path or equation of the trajectory. So how can we get the equation of trajectory? Just by eliminating the time. And the thing is, how basically you can eliminate the time. I am telling you, I'm not going to derive here. See, look at this equation. Can you write cos kz minus of omega t is equals to ex upon a? Can you write like this? Similarly, just look at this equation number 2. Take it as c, take it as the d, cos c plus d. Use the formula, split into the cos and sine terms, and if this is the cos, the sine kz minus omega t, you can write like this, root under 1 minus cos square theta, that is 1 minus ex square over a square. You can write like this. Okay, just expand from here, put the value of sine and cos, and finally you will arrive on a general equation which does not include the time, and the equation is, I'm going to write here, this is ex square over a square plus ey square over b square minus 2 ex ey over ab cos phi, and this is equals to sine square phi. Okay, this is the general equation, this is the master equation we have, and with the help of this equation we are going to find out what are the condition on the phase difference and the amplitude for different polarized light. Okay, so in this video I have given you a complete description about this equation. Now I'm going to tell you how can you see whether the light is plane polarized. So I'm going to tell you the recognition of the plane polarized light. Okay, so I can write here. See, first of all, I'm going to take phase difference. If you take phase difference, phi is equals to 2n plus 1 pi by 2. You can first go for the plane polarized. So just write phi is equals to 2n pi. Just for this, okay? 2n pi. So if the phi is equals to 2n pi, take n is equals to 0, 1, 2, and so on. So your phi will become what? 0, 2 pi, 4 pi, and so on. Okay? Put the phase here. So look at it. What will happen? The sine phi, that is sine 0, sine 2 pi, sine 4 pi, all will become 0. And this will give you plus 1. Cos 0, cos 2 pi, cos 4 pi, all will give you plus 1. And it will be a minus b whole square. Right? When you solve this, you will finally arrive on this equation. Ey is equals to minus b upon a plus b upon a times of ex. Okay, this is your final equation. Just look at this equation. Is it a straight line equation, right? Y is equals to mx plus c form. So if this is a straight line equation, that's for sure that the tip of electric field is going to span in a straight line, which I told you in the last video, like this. Just look at here. I'm going to draw this again. So x-axis is the y-axis. Ey, Ex, and like this. In this way, the tip of electric field going to span the straight line. Okay. What we have done, we have used a general equation, we have put the phase difference, we have arrived on this particular equation, and just after plotting, we are seeing that the tip of electric field is spanning either up or down, or up or down, right? See, what will happen if you change the amplitude? The change means if you take the same amplitude, where B and A are different. See, if you take A is equals to B now, also not going to affect this. So it will what? Ey is equals to Ex. That's it. Again, it's a straight line. And if this is a straight line, then again it's going to span in a single plane, right? That's called the plane polarized light. Okay. So what is the recognition of the plane polarized light? Phase difference is 2 and pi. See guys, if you want if you want now, you can also take a pi is equals to 2n plus 1 pi. It's nothing going to change again. If you take phi is equals to 2n plus 1 pi, if you take n is equals to 0, 1, 2 and so on, the phi will be what? Pi, 3 pi, 5 pi. And when you use this now, when you use this phi is equals to 2n plus 1 pi, where the change you will get, I'm telling you, not a very big change, just you will get a minus sign over here. Minus b upon a ex. So what will change? The slope. The slope will change, okay? So after using the 2n plus 1 pi, you will get Ey is equals to minus b by a times x. So nothing is going to change except the slope. What should be the new curve? I'm going to draw here. Let's look at here. See, this is your x-axis and y-axis. This is nothing but Ey. This is your Ex. Now, for this particular case, this will be the slope. This will be the slope, the negative slope. That's it. So then the nature is not going to change. Nature is not going to change. Nature is again a plane polarized because again the electric field is spanning in a straight line, right? This is again a straight line equation and the electric field is spanning in the up and down. So finally what we can conclude here, if the phase difference is 2n pi or 2n plus pi, no matter what are their basically amplitude, whether amplitude can be same or amplitude can be different, you can say the light is nothing but a plane polarized light. Plane polarized light. Okay. All right. So this was the recognition of the plane polarized light. In our next video, I'm going to tell you how basically you can recognize the circularly polarized light. Okay. And then after the electrically polarized light. Thank you guys.